Unit 3 test, part 2, congruence and constructions. This test is worth 20 points. You must show all of your work for credit. Directions: answer the following questions and submit this test to the assignment Dropbox. This video should be used to help you answer the questions on the test. You should pause the video after you answer each question. So pause the video and you can answer your question, then come back and resume. Number 1, identify the triangle congruence postulate listed here that proves that the triangles are congruent. If the triangles are not congruent, then state they are not congruent. This is worth 6 points. You get 1 point for each correct congruence postulate. Triangle congruence postulates are listed at the bottom of the document. So you've got 6 of these triangles that you need to prove are congruent or state that they are not. So at the bottom of the document, I'll scroll all the way down, you can see rules for triangle congruency. And just for example, this first one, this side is congruent to this side is congruent to this, and this side is congruent to this. Therefore, these two triangles are congruent by the side, side, side postulate. So that's an example. So you've got this listed at the bottom of your document. Let me go back up to the beginning, and you can type in these boxes right here. If you click on the boxes, you can type in there which postulate it would be. So you're going to choose from these listed at the top: side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. And again, you can see the examples at the bottom of the document. So you're going to fill in these for 6 points. If you'd like to pause, I'm going to go ahead and move on to number 2. So pause the document and come back. Number 2, use rigid motions to explain whether the triangles in the graph are congruent. For help, use the coordinate transformation rules at the bottom of the document. So we've got some triangles. ABC, this triangle right here, went through a transformation to get to A prime prime B prime. Oh my gosh, my mouse. A prime prime B prime prime C prime prime. So it first came from this one right here, ABC. This mouse. And then it went to A prime B prime C prime. And then it moved another transformation and it went to A prime prime B prime prime C prime prime. At the bottom of the document, you can see the rules right here, coordinate transformations, and you can go ahead and see what has happened to each point, and then you can look at what happened to it. Or you can eyeball it and see what has happened. So you need to answer these questions. What was the first transformation rule? So what was the rule that went from here to here? What was the second transformation rule? How did we get from this one to this one? And these are each worth 1 point. You need to know what rigid motion means, and you're going to put your definition in here, 1 point. Are these triangles congruent? And you need to explain to get the 1 point. Are they congruent? So you need to know these two are definitions. You can pause right now if you'd like to finish number 2, and we'll move on to number 3. Number 3, complete the construction of a perpendicular bisector of a segment AB. This must be done by hand or by using MathsPad. We went over this in class and we did this exact construction. Take a screenshot or picture of your work and add it to this document. If you want to see it work through or see the directions, I put the web page right in the document. It'll walk you through it, but you need to go ahead and construct it. Leave all of your marks when making the construction using your compass. No marks equals no points. What does that mean? If you are putting a mark on your document to find the perpendicular bisector, you need to leave the marks on there. Here's the link from MathsPad if you want to open this up. So you've got a link with directions, MathsPad, and you should put your image right here. I don't want it as a separate document. I need you to put it right here on this document. We're going to move on to the last one and number 4. So if you want to pause and do number 3, you can go ahead and do that. So number 4, we have 2 different triangles. Triangle ABC. ABC is congruent to triangle DEF. Find the length of the side from D to F. So that's this length right here. Show the equation and all algebra used to solve for the length from D to F. This is worth 6 points. 1 point for correct equation, 4 points for the correct algebra process, and 1 point for the correct length of D to F. You must show all your work to receive any credit. So you can type right in here all your algebra, how to find that. So remember, order matters. The length of the line segment AB is congruent to the length of the line segment DE, and so on. So look for the corresponding lengths of the lines and solve for the length of DF.